Welcome to the Byrne-Wheeler Report. I am Joe Byrne, and today is June 15th, and it's good to be back in the saddle. How are you doing, Bob?
Hey, Joe. Great. Doing great. And I know it's been a little while, so we got a lot to catch up on here.
Yeah, in one of our recent episodes, I think it was the one before last, it was the memory episode, and we had Gary Spurden of MEXT on. And just as we record this, the press release came out that AMD has acquired MEXT.
Yeah, big news. Of course, no financial terms were included, and my one of my pet peeves with the SEC is there are no hard and fast metrics for what is considered to be material. So companies are left to their own devices to decide whether an acquisition is material or not, or immaterial.
Well, I think the key takeaway for our viewers and our potential sponsors is when you sponsor a Byrne-Wheeler episode, you should expect to have a juicy exit within a month or so.
There you go.
So turning to that, in the past several weeks, we've had earnings announcements from Broadcom, Marvell, and Nvidia. Bob, what do you think about what they disclosed?
Yeah, well, I'll start off with Nvidia. It's just kind of staggering that at the scale that Nvidia has grown to, that they're still able to grow their data center revenue 92% year over year. It's just kind of hard to wrap your head around a number like that when you look at the top line, right? The other interesting thing.
Right. That, if they were $100 million company, say, oh, sure, they doubled it, things are going great. But when you're doing 30 million a quarter or whatever, it's a different 30 billion a quarter. It's a totally different story.
Billion with a B. And the other thing that was interesting is they've changed their reporting structure now. So they have this new breakout of hyperscale versus everything else essentially on the data center side, and they call it ACIE, and don't ask me what that stands for. It includes neoclouds and enterprise, and it's basically everything that's not hyperscale.
Right.
And then from a product standpoint, they now have data center and something called edge computing, which is absolutely everything else they do. So it used to be, gaming and automotive and professional graphics, etc., and now it's all lumped into this edge computing bucket since it's become a rather small portion of the overall revenue. But fortunately for us, they still reported the old breakout of data center revenue. So they reported the networking revenue as $14.8 billion, up 199% year over year.
So that's tripling year over year.
It's crazy. And Nvidia now claims to be the world's largest data center networking vendor, which is pretty hard to dispute at that revenue level because you can't really look at any competitor that even comes close. And, of course, we've talked a little bit here about the business model, and okay, it's not necessarily chips and sometimes it's systems. That also relates to the Vera CPU outlook, where they've talked about having visibility to 20 billion in Vera revenue this year.
Right.
But I think as you and I discussed,
that's for a new entrant into, server processors to go from zero. Not zero, but a small number to 20 billion. That's bonkers.
It's bonkers. But I think as you and I have discussed, it's probably not really just CPUs. It's probably CPU modules, which then include the SOCAMM, LPDDR DRAM. And it's definitely a higher ASP than a typical server CPU sold as just a bare chip, right?
Right. Although, one way to track it kind of on a unit-ish basis would be to look at ARM's revenue as it ramps, because even if we don't know what the royalty rate is, the growth rate that ARM is reporting is going to be dominated by the ramp of Vera, I suspect. And so that'll help us triangulate into kind of like a little bit kind of a different level of detail.
Yeah, that would be helpful because, the top line number is just, as you say, bonkers. So anything else on NVIDIA you wanted to mention?
No, I was just going to point out their claim of being the world's biggest networking company. And I think the other thing that they mentioned, going back to Edge, which is they are becoming substantial in edge AI, and I see this as a threat to the traditional embedded processor suppliers. And that includes Marvell, but also includes companies that make smaller scale chips like NXP, ST, TI, companies like that. And, there's suddenly this big player that's in their turf. One adaptation is Nvidia and NXP have some kind of partnership. And I think NXP said, okay, if you're going to build a robot or any other kind of edge AI system, we'll do the microcontrollers and we can handle some AI at that scale, but the big high value chips will be NVIDIA's to claim.
Yeah, and I mean, similar to the MediaTek partnership for the PC chips, right?
I think that's a little different in that I think NVIDIA had the wherewithal to go after that market independently. It's already supplying the PC market with GPUs. I think in that case was more of like NVIDIA saying, okay, we'll do our piece, but we'd like to have a partner. We'd like to share the work here and keep ourselves from getting bogged down. And plus, like those two companies have a history early on in NVIDIA's life. It was on life support and MediaTek saved their bacon. So they have good personal relationships.
So moving on to Broadcom, I mean, Broadcom, what was stunning was they announced great results in the stock tanks.
Well, yeah. I mean, wasn't part of that, Bob, that Google is spreading some TPU love around, and that was the
part
trigger,
of that was,
or
I think part of that was margin compression was a concern, and that relates to the Google business, and their gross margins are going to suffer if they're selling more TPUs. But it's hard to. It's hard for me to see a negative in that.
Yeah, it's not exactly the bear case. I think even with Google diversifying, I think part of it is they want to have, first of all, I think they're proliferating their designs. So it's not just one or two TPU additions per generation. My guess is they're going to do more, and so they need to farm out the work. And moreover, there's access to capacity, so there's a certain amount of capacity allocated to each of the ASIC suppliers, and Google wants to tap into, make sure that they're not caught flat-footed and without the resources they want.
Yeah, so back to Broadcom, I mean, their AI revenue grew 143% year over year to $10.8 billion, so pretty impressive revenue growth. Kind of even greater top-line growth in AI revenue than NVIDIA. Of course, the numbers are, not of the same magnitude. Networking was nearly 40% of the AI revenue, which is kind of at the high end of their usual range of like 30 to 40% of the AI revenue should be networking. The other interesting...
I was going to say, do you have any sense of why that was? Because their networking revenue and NVIDIA's are growing simultaneously. It's not like there's a trade-off between one versus the other.
Yeah, I think it's, in Broadcom's case, I think it's the Tomahawk 6 ramp. And so, and for NVIDIA, it's probably the Spectrum X ramp. Although NVIDIA also reported huge growth in InfiniBand. So even though, Ethernet's growing fast at NVIDIA, the InfiniBand, I think, quadrupled year over year or something. So, I mean, it's just sort of a rising tide here at the moment. And the other interesting thing that came out of the Broadcom earnings call is they mentioned taping out a 200 terabit switch this quarter. So I'll call that Tomahawk 7. They didn't call it Tomahawk 7, but that would be the usual naming structure. And I would expect that will be still 200 gig Serdes, but 1024 Serdes, which is something that...
Wow. That's going to be a massive package.
Well, so they already have a version of Tomahawk 6, which has 1024 by 100 G Serdes.
Well, they do.
They do. And so, yes, they are pushing the limits on packaging with these giant chips. And then Hawk 10 did mention 400 gig Serdes coming in 2028, so that would be kind of the 400 gig generation in 28.
Right. And then do we go back to 500 pins or lanes per package, or we're gonna stay at 1,000 and bank
They probably do both. Probably do both because that giant package does have its downside. So I would expect they would do both, as they've done with Tomahawk 6. And interesting thing is to do that, they used a chiplet for the Serdes. So they have the core switch die, and then they have chiplets for the Serdes, which is a first for Broadcom. Everything had been monolithic.
They've kind of poo-pooed their competitors that have gone chiplet in the past, talking about how they can get good Serdes performance in a monolithic design. But
which is ironic because Marvell just announced their T100, which is supposed to sample this month, and it's monolithic. So Marvell's gone the other direction to a monolithic 3 nanometer design for their 102.4T switch, and they're claiming superior power, although, based on what's been disclosed so far, it seems like Marvell's design and Broadcom's design are in the same realm. They're kind of in the kilowatt, basically kilowatt power range. And, frankly, power has become less of a concern with the advent of liquid-cooled switches and these high-density AI rack environments.
Yeah, once you're running liquid cooling for the AI processing, you've got the plumbing, quite literally, to cool the chip.
Yep.
Did you want to spend another minute talking about Teralynx before we move on to the Marvell earnings?
Yeah, Broadcom and Nvidia are already in production at 102.4T. Cisco says they'll ship systems this year based on their Silicon One ASIC at 102.4T. So, Marvell is behind from a time to market standpoint, but their key customer is Amazon, and they seem to have retained the business there. And in fact, kind of going back to the Marvell earnings, they're forecasting $600 million in data center switch revenue this year, which would be driven by the ramp in 51T. So, they've got a pretty substantial business from that former Innovium switch line.
Yeah, that's really not a bad piece of business. Going back to the monolithic versus chiplet, does going to 1,000 lanes per switch chip, does that effectively necessitate a chiplet? Like, do you need kind of like offboard Serdes just to be able to fan out to the package periphery? Or is it more of the traditional, like, for signal integrity, we really need to put these in a different process or, an isolated chiplet?
No, it's different. It's the same process. I'm not sure about whether the fan out is really kind of required at that point, but it's the same process. And I think the main thing for Broadcom was the ability to do 2 different versions of Tomahawk 6 and
economically mix and match without having to do a whole new switch core chip.
Yeah, exactly. So I think that was the main motivation as I understand it.
Yeah, that totally makes sense. All right, Marvell, what were your thoughts on Marvell earnings?
Well, so, Marvell's data center revenue, which is now 3/4 of their revenue, basically, 76%, I think it was specifically. Their data center revenue was up 27% year over year, which is nice, but then it seems really lackluster after looking at Broadcom and Nvidia, right? So
it's also smaller in absolute terms. I think it was on the order of $2 billion compared to 10 for Broadcom.
Absolutely, much smaller, and but they are forecasting 40% top line growth this year. So clearly, they're expecting this to be a back end loaded year, and that's probably driven by some Amazon business. So I think we'll have to kind of wait and see how the rest of the year goes for Marvell. But it comes down to the timing with these really large customers, right? And product cycle timing.
Broadcom benefits from having been supplying, Google and its other ASIC customers for a longer period. And so it's kind of already ramped up to its level. And it, of course, has the bigger, it's always had the bigger networking business as well. So people are going to buy their networking, independently of their ASIC business.
Yeah, absolutely. They're selling plenty of networking chips alongside NVIDIA GPUs. So
next on our agenda, and this will be a quick one, is Tensordyne, formerly known as Recogni. They've just announced today that their latest chip is available. I'll just keep it brief. The key technology that they have that differentiates them is they do AI processing in the log domain. So in the log domain, multiplications become additions. So multiplications being requiring more circuitry than additions and therefore consume more power. So in theory, you should be able to get more operations per chip and more operations per watt with this approach than the the traditional approach of doing multiplication by multiplying.
Interesting. So where and how does the conversion happen, I guess?
Yeah, they would have to do the conversion offline. So when you prepare the model and to be pushed on to the the particular NP or what have you, there you do the conversion there. I don't think they do the conversion on the fly because otherwise you have to take logarithms, which you can do, but like why do it on the fly when you have to load the model up, a static model anyway? So do it offline.
Right, right. Interesting.
Less processing and networking related specifically, but Huawei talked about their logic folding technique and using it as an example of tau scaling, where I think tau is, it's not TAO as in the Chinese word, but TAU as the Greek letter.
Yeah, referring to time, I believe.
Right. So the idea here is at whatever different level, whether we're talking about systems or all the way down to circuits, how do we improve the time? So in a circuit, how do we shorten the propagation delay between one flip-flop through logic and to another? And that's, that particular case is where the logic folding comes in. And it's a mixture of something old and something new. So the old part is hybrid bonding. And so you take die and you stack them together. It's what we do with HBM. It's what, say, AMD does with its V-cache. The difference here is the granularity. So the idea, going back to one flip-flop, sending a signal to another, there are going to be cases in traditional planar circuitry where that's a long path. But if you could move the logic and the flip-flop to another die located vertically, you could have a shorter path and less impedance, and thus you're reducing your time constant. And so that then necessitates a different approach to EDA because you're going to be synthesizing and placing and routing over 3 dimensions versus what we do now is we tend to stay in the planar domain, but then stack planes on top of each other. But this is more about how do we actually organize logic in 3 dimensions. So, I mean, it's unique. It's different.
Yeah, and I mean, basically, it's an answer to not being able to keep up.
Yeah.
The claim is that it'll be 14A equivalent density by...
Right. Well, I forget the year, maybe 2031 or something. I don't interpret that literally because the critical dimensions are still smaller. We'll see. We'll see what the overall system performance is. As we discussed in our memory issue, when we talk about HBM and how the TSVs take up so much area, you end up losing a lot of density, and we'll see what actually materializes from this approach. It's useful or it's interesting, let's say, but how useful it is, I think, is still TBD. And then on the tau scaling, I mean, Moore's law is an economic statement, right? And it was the observation that, hey, every 18 months, 2 years, we seem to be able to get twice as many chips or twice as many transistors for the same dollar. And, we're off that trajectory. But Dennard scaling is what people normally mean when they talk about Moore's law, and that's the doubling of transistor density every generation and power reduction, and for that matter, the reduction of distance between, say, flip-flops. So we haven't been doing Dennard scaling for a while. And I think Tal just says, hey, let's focus on performance, which, at the end of the day comes down to time. So it's, I don't think it's bogus. I think it's trying to refocusing our attention on one aspect of things that matter. It ignores power and density. It just tries to quantify or set a roadmap for technology gains that's, in a metric that's this tau-based metric.
So they did say 2031 was the target for having tau scaling deliver transistor density equivalent to 14A. So, I mean, it does give them 5 years to get there.
Right. One thing they pointed out was they're fairly relaxed in their top-level metal pitch that they do, which is where the die mate. And so they could tighten that up. That would probably give them like a 2x scaling, and then they have to somehow get to finer geometries, which maybe could give them another 2x. So you can kind of see how they could get there without, miracles happening.
Okay, so we had Computex and kind of co-located, we had GTC Taipei.
Right. Yeah, this thing's kind of blended together. They're, out of Nvidia, the big announcement was the RTX Spark, which is similar. I think it's the same chip as the DGX Spark, which is the small form factor PC, but it's now available in laptop form. So ARM-based CPUs developed by MediaTek with a separate die that has a big NVIDIA GPU on it.
Yeah, I mean, do you think it's going to actually make a difference in the market, or is it just kind of a first-generation product to seed the market?
Yeah, I see it really as the latter. It's a first-generation product. It obviously had gestational problems, and the easiest evidence, or the most obvious evidence, is the CPUs are like ARM Cortex X925, so they're at least one, if not two generations old at this point. And not that makes a huge performance difference, because the subsequent CPUs are more or less the same microarchitecture, but with improvements. I definitely see this as that first generation design, get it out the door, see what the customer response is, get it in the hands of developers, and at some point you have to call the project done and see where it goes, because when it hits the market, they'll get different kind of feedback than if they waited for the next gen product.
Yep, absolutely. So kind of maybe circling back to Marvell for a moment. So Matt Murphy gave a keynote talk at Computex, but really there was no particular news from Matt, from Marvell, but what did happen is Jensen came on stage and did a cameo and proclaimed that Marvell would be the next $1 trillion market cap company. And so Marvell
as we talked about in the earnings discussion, they have a little ways to go.
They do have a ways to go, but it definitely moved the needle and put a lot of focus on Marvell. And I mean, it's interesting in that Marvell's also kind of an ASIC supplier, right? But I think NVIDIA looks at them more as part of the ecosystem and less as a competitor, maybe relative to Broadcom in particular.
Why do you think that is? More because, I mean, they are roughly similar in that they provide the ASIC services and the networking, and so thus they're providing alternatives to what NVIDIA offers.
Yeah, I think it's because the networking and interconnect business at Marvell is a much bigger piece of their business, right? And they've worked with NVIDIA for many years on the interconnect side of the world. And so I think they probably look at Marvell as more the plumbing in the data center and not as much of a direct threat to the GPU business.
And at the same time, NVIDIA has offered their interconnect standard to other companies to use, NVLink, C2C, NVLink, and there are NPU designs afoot, right, that would work with NVIDIA chips. So,
correct.
And those are less threatening than, say, TPU, which would probably never do that.
Yeah, so Amazon did announce last year that they would have support NVLink in Trainium 4, and so they've kind of committed to supporting both NVLink and UA-Link in the Trainium 4 generation. And so, yeah, that ties into the kind of NVIDIA ecosystem and the idea that Jensen says, you don't have to buy everything from us, but at least buy something from us. And of course, the preference is for customers to buy everything, but they're willing to work particularly with the hyperscalers who, of course, don't want to be completely locked in on all levels.
Right. And when you're doing, what is it, 75 billion a quarter? What's the number for Nvidia? And compared with this other data center company doing 3 billion, it's, it's hard to feel particularly threatened, perhaps. Anyway.
And then I think the last Computex item I had was the announcement from Intel of inference racks with SambaNova.
Yeah, this kind of interesting tie-up. It goes back to a notion I think that you introduced in one of our previous episodes of heterogeneous compute. So, I mean, clearly we don't have GPUs or NPUs independent of CPUs, but this rack concept, you have a GPU of undisclosed provenance that will do the decode phase of a transformer-based LLM, and then SambaNova with their data flow architecture can crank out tokens in the encode phase. And so this heterogeneous processing and collaboration on one task, and then favoring Intel as the CPU supplier. And, I think in the announcement, go ahead.
So is that Crescent Island then on the GPU?
At this point, I don't think it was disclosed.
So I think they're going to talk about Crescent Island at Hot Chips in August.
And the Xeon 6 is the Clearwater Forest, which I think it was about Clearwater Forest, which is the 6 Plus, which is the all E-core Xeon. And it's interesting in that, well, first of all, it uses Intel 18A, so as they ramp that process, they're making their server chips in their own process. But it also has a different approach to die stacking, where they move caches off the main chip. And so you can get high compute density and still have big caches, which should be good for workloads where you need to have a lot of data local to the CPU, but the CPU doesn't necessarily have to be an IPC or otherwise, instruction throughput beast, but rather you want to have a lot of these CPUs and a lot of data capacity nearby.
Okay, interesting.
Yeah, so anything else on your mind, Bob?
Nope, I think that catches us up as of this morning's AMD news.
Thanks for joining us at the Byrne-Wheeler Report, and we look forward to you joining us at our next episode. Bye-bye.
It's all about the panties, baby.